Nice to be here today to share some exciting information about new developments in cold climate heat pump technologies. I'm specifically going to be chatting about air-to-water heat pumps today. And in case you haven't heard of what an air-to-water heat pump is, don't worry, we'll start at the beginning with what is an air-to-water heat pump. Luckily, it's a pretty simple answer. Air-to-water heat pumps are air source heat pumps with hydronic distribution. So they're very similar to air source heat pumps, if you're familiar with those. They just distribute the heat through hydronics instead of an air distribution system. To look at this a little bit more closely in a schematic view, here's an example of a very simplified air source heat pump schematic. On the left-hand side, you have an outdoor heat exchanger moving heat into a refrigerant, and then you have an indoor heat exchanger moving heat from the refrigerant to the air in that indoor space. And similarly, an air-to-water air source heat pump has those two heat exchangers, but one of the heat exchangers, the one that's would usually be providing conditioning to the indoor airspace, instead sends that heat energy into a hydronic loop, a water loop. And then that water can be used in various ways to distribute the energy that the air source heat pump has moved from the outdoor air into the building. And that hydronic distribution can look like radiators, radiator slabs. It can look like domestic hot water heating, lots of form factors. And hydronic distribution systems are really versatile in terms of how they can be set up, and they can be very efficient in terms of how they move heat around a building. And so that's one reason why you'd go to the bother of making an air source heat pump into an air to water heat pump. There are lots of words for air to water heat pumps. I'm going to be calling them air to water heat pumps today. They are also known as air source heat pumps, which is what I mentioned. They're just a type of air source heat pump. You might have also heard them described as heat pump boilers, as combi heat pumps. That's usually reserved for when the heat pump's providing space conditioning and domestic hot water. And you might also just have heard it called a heat pump water heater. Technically, heat pump water heaters that do only domestic hot water heating are air to water heat pumps. But usually in the industry, heat pump water heater means it's just serving potable water supply, whereas air to water heat pump usually means space conditioning is involved. If this terminology wasn't enough for you and you wanted more, there's multiple different kinds of air to water heat pump configurations. And the three major types are shown here in images here. The first is the monoblock style. Everything's in one big box. We've got a split style where you have an outdoor unit and an indoor unit. And then there's even third-party split where you have an outdoor unit and an indoor unit, but you can mix and match. They're not necessarily needing to be made by the exact same manufacturer. Looking at the schematic again, taking a closer look on exactly how those systems are different in terms of monoblock versus split. In the monoblock case, all of the important stuff that makes up what the bare minimum of an air-to-water heat pump is lives outside in a rather large box, and it's only hydronic lines, water lines, that penetrate the building envelope. And these monoblocks, even though everything you really, really need is outside in the outdoor unit, they often have optional indoor units that comprise of pumps or valving or controls that simplify the installation, making it so that there's less connections to make indoors. So a monoblock system sometimes still has an indoor system, but it doesn't necessarily need one. And the key characteristic is that it's water lines that are going into the building. For split systems, they have refrigerant lines that enter into the building, and it's in the indoor unit that refrigerant to water heat exchanger lives. And that then interfaces with any kind of distribution you might want. You can add auxiliary heat sources, you can add different types of emitters, and you can add different types of loads like space conditioning or hot water to either of these systems. And they're just essentially two different styles of the same sort of technology. The benefit of the monoblock system is that you don't need to do refrigerant charging in the field. That can all be done in a manufacturing setting. and the connection to the home is really all water lines, which requires a different skill set than doing refrigerant work, which is required still for our split systems. So that is an overview very quickly of what an air-to-water heat pump is, but I have some exciting results to share with you today about a field study that we did that actually installed these kinds of air-to-water heat pump systems in cold climate homes located in the tundra of Minnesota, where I am today. It's actually not that cold today. But the case study we did we started in about late 2021, finished up in 2023. And our goal was to evaluate different air-to-water heat pump systems that are currently available or were currently available for the residential market to serve cold climate located homes for space conditioning. And we ended up field monitoring 4 different homes retrofit with air-to-water heat pumps. So these homes were not new builds. They weren't designed. The home itself wasn't designed with an air-to-water heat pump in mind. And we simply upgraded their HVAC systems to have air-to-water heat pumps. And we evaluated these systems for energy savings, costs, and performance. To summarize what kind of air-to-water heat pumps we installed, we had 4 systems, 2 of which, the first 2, 1 and 2 in this table, were relatively simple systems. They were third-party split systems, so they had basically very simple controls. We happened to pair a coil-only air source heat pump with Norair air-to-water heat pump unit, and both of these homes had in-floor heat, meaning the emitter in these homes was a radiant slab. All sites also had auxiliary electric resistance boilers in case there were problems with the air-to-water heat pump or the air-to-water heat pump could meet the entire heating load. And the first 2 sites didn't have any cooling and didn't have any domestic hot water. So those air-to-water heat pumps were just providing space heating. At site 3, we cranked up the complexity and we had space heating, space cooling, and domestic hot water in a 2-story home. The basement had radiant in-floor heat. The upstairs had a centrally ducted propane furnace upgraded with an hydronic coil, which could provide cooling and heating. And then also the air-to-water heat pump was set up with a domestic hot water preheating tank, which fed into a traditional electric resistance domestic hot water tank to preheat all the incoming water so that there was less domestic hot water load. And then our final site was very similar to site 3, but we skipped the domestic hot water. So it had floor heating, space cooling, and space heating through that hydronic coil with a backup propane furnace. This is what the systems look like in real life. So here's what the systems of the third-party split systems we installed look like. Inside, there's the indoor unit, which includes that refrigerant to water heat exchanger, and that then interfaces with the hydronic heating system. In this case, the manifold at the bottom of the image on the left is what's distributing the water lines throughout the floor in the home to various different zones. And that picture on the right, if I hadn't told you this was set up as an air-to-water heat pump system, you might have thought it was just an air source heat pump, because it is. To be clear, air-to-water heat pumps are air source heat pumps. That's one of my points I'm hoping y'all can take away today. So that's what the third-party split system looks like. And here's our monoblock air-to-water heat pump system that has the space conditioning and domestic hot water preheating. The units that we did install for monoblock systems were provided by the manufacturer also an indoor unit. This is not technically required for a monoblock, but this particular manufacturer has a lot of their controls built into the indoor unit. So it is an integral part of this specific model. And that's the large box that's brightened by a light on the left-hand side. And that box interfaced with the domestic hot water preheating tank, which is on the right side of the left-hand picture, and also had lines that went across the room to a air handler, which had a propane furnace and the hydronic coil to provide heating and cooling through a ducted system. And as I mentioned, the outdoor units of monoblock systems are pretty large. So my colleague in this image is about 5'10", to give you a sense of scale on how big that outdoor unit is. And very similarly, here's the monoblock system at the fourth site where domestic hot water service was not included as part of the load for the air-to-water heat pump system, but it did have an air handler and radiant slab. All right, so that's what the systems look like in reality. What did they perform like? Here are our two split system homes, and these plots are showing how much load was delivered on average per day as a function of outdoor air temperature, where the blue bars indicate how much load was delivered by the heat pump, and the red indicates how much was delivered by the backup boiler. In both cases, the majority of the heating load for the whole heating season was provided by the air-to-water heat pump, and the boiler was primarily serving the heating load during the coldest part of the year below 0 degrees Fahrenheit. The controls for these third-party split systems are relatively simple, so we did see sometimes boiler operation during temperatures where the heat pump should have been able to supply the entire heating load. And that is a function of the fact that the controls were set up to prioritize the speed of meeting set point rather than efficiency. And here's how much load was delivered by our monoblock systems, site 3 and site 4. Again, here, these controls are a little bit more complex and sophisticated, so we see a lot less boiler usage in mild temperatures, and we again see the majority of the heat is delivered successfully by the air-to-water heat pump, and it's only in the very coldest weather where the boiler has to take up the majority of the heating load that is below -5 degrees Fahrenheit. Though these particular units could operate as cold as -13 degrees Fahrenheit. In terms of energy savings, they were significant for these sites. So the energy use for space heating decreased by as much as 50% at our case study sites, meaning savings of almost as much as 25,000 kilowatt hours per year. Those savings were highest for the higher specification units, those monoblocks. But even the very simple and much less expensive split systems delivered significant savings, at least 27%, even though those systems were relatively simpler. In terms of domestic hot water savings, that one site that we did have domestic hot water service at saw huge domestic hot water energy savings. The hot water load was reduced by about 30% to yield an annual savings of more of 40% because the load was more efficiently met by the air-to-water heat pump than by the existing electric resistance hot water heater. This particular site, I did want to know, did have particularly high domestic hot water load savings, or just a really high hot water load. They had several teenage boys in the household. I don't know if you have spent any time with teenage boys, but they can shower an awful lot. So the kilowatt hour savings for the typical home is probably going to be about half as much as what we're seeing here. But still, the savings are quite significant. And that's with the system simultaneously providing space conditioning and cooling. It only supplied domestic hot water when it wasn't already doing space conditioning. All right, I'm running out of time here, so I'm just going to zoom through the key takeaways I hope you can take with you as you leave this short talk today. First of all, I want to point out that air-to-water heat pumps are air source heat pumps. So this is not a brand new technology that no one's ever heard of. It's just a new iteration of an air source heat pump. And they are available now and there are systems that are already out there that are capable of performing excellently, even in cold climates. In the very coldest climates like Minnesota, supplemental heat is still typically required for the very coldest hours of the year. But these systems are compatible with many different kinds of emitters. In our study, we focused on low temperature radiant slab emitters because we're concerned that retrofitting high temperature emitters, or like cast iron radiators that are designed for supply water temperatures as much as 160 degrees, might struggle to supply the load when the supply water temperature from the air to water heat pump is only like 120 degrees. But yeah, the savings are significant, and this is a great opportunity to get in early with. So I think I've run out of time, but here are all the folks who worked on this project. You can reach out to us anytime if you have questions about this work or air to water heat pumps in general. Armando, do we have any time for any questions that might have popped up in the chat?
Thank you. First of all, thank you, Samantha. Really appreciate the talk. Very succinct and clear. Based on your experience, do you see much interest from HVAC manufacturers in air to water heat pumps? They are pretty common in Europe, but their adoption doesn't seem to be as quick to be in the US.
The question, I am assuming, is that air to water heat pumps are common in Europe, but not being adopted significantly in the US. Why is that?
Yeah.
Part of the reason is that air source heat pumps in general have had lower adoption rates in the North American markets, and air to water heat pumps being essentially a more complicated version of an air source heat pump sort of has been a reason for the delay. Also, hydronic heating is a lot less common across North America as compared to the European Union. And we have just a smaller workforce that's doing hydronic heating systems in general. We also have a lot of hydronic systems in the North America that were designed for high temperature emitters. So we didn't prove that works with air to water heat pumps, and that's an area of continued research, in my opinion.
Great. Thank you, Samantha. Well, I will say we are out of time. You had a total of 11 questions asked during this, so a lot of engagement. People are very interested in this technology as apparent through the Q&A, but I will invite folks to jump over to the other session. I'll try and get all of these questions over to Samantha so she can answer them offline, but thank you so much, Samantha. Thank you, everyone, for joining this session, and we'll see you in the next one. Thanks again.
Thank you.